Every second, deep beneath Iceland's surface, the Earth's crust continues to shift by a few centimeters, a movement so slow and silent that it goes unnoticed by human senses, yet powerful enough to reshape entire landscapes. This constant motion has created more than 130 active volcanic systems across the island, carving kilometer-long fissures into the ground, and releasing molten lava heated beyond 1,100 degrees Celsius. At those temperatures, lava does not simply burn or damage structures, it erases them entirely, capable of covering and destroying an entire town in a matter of hours. Faced with forces of this magnitude, humans cannot extinguish an erupting volcano or halt magma rising from deep within the earth. The only option available is to slow the inevitable, to build barriers that delay destruction and buy time against a natural process that cannot truly be stopped. In today's video, join Mandarin Tech as we explore a critical question humanity continues to face in volcanic regions. Can humans actually stop lava, or are we merely postponing the moment when nature ultimately prevails? Despite its nickname as the Land of Ice, Iceland is one of the most geologically active regions on the planet. The island sits directly atop the boundary between the North American and Eurasian tectonic plates, which are slowly pulling apart. As these plates separate, magma from deep within the earth rises toward the surface, fueling frequent volcanic eruptions. In many cases, lava flows harmlessly across uninhabited fields of hardened basalt, reshaping landscapes that were already forged by previous eruptions. However, when lava changes direction and moves toward populated areas, infrastructure, or critical energy facilities, it immediately becomes a serious threat. On average, Iceland experiences around 4 volcanic eruptions every year, and despite decades of research, scientists still cannot predict exactly where the next eruption will occur. This uncertainty means that preparedness is never optional, it is a constant necessity. When the eruption that began in 2023 spread across an area of approximately 15 square kilometers, Icelandic authorities responded almost immediately. A massive, coordinated operation was launched with one clear objective: slow the advancing lava flow before it reached vital infrastructure. The solution was the construction of lava barriers, enormous earthen walls designed not to stop lava entirely, but to redirect and delay it. These barriers are not fully designed in advance like traditional dams or levees. Instead, they are built continuously and adaptively, responding in real time to the movement of molten rock. Behind one of these towering walls stood a geothermal power plant, a facility responsible for supplying hot water and energy to a large portion of Iceland's population. If lava reached this site, the consequences would extend far beyond physical destruction, disrupting daily life for tens of thousands of people. At the peak of construction, the lava barrier reached a height of nearly 20 meters. Over the course of 6 months, more than 3 million cubic meters of material, primarily volcanic rock and soil, were moved to form this embankment. Even then, the lava did not simply stop. In several locations, molten rock overtopped the wall, forcing firefighting crews to spray massive volumes of water directly onto the lava. The goal was not to extinguish it, which is impossible, but to cool the surface just enough to slow its advance. Each minute gained allowed engineers to reinforce and raise the barrier further, buying precious time in a race against gravity and heat. Structurally, lava barriers are deceptively simple. Unlike hydraulic dams or concrete flood defenses, they consist mainly of layered earth embankments built 1 meter at a time. The key difference lies in what they are designed to stop. Lava does not seep through soil the way water does. Its extreme viscosity and temperature cause it to flow across the surface, guided primarily by terrain and elevation. This allows engineers to focus on increasing height rather than complex foundation work. As long as the barrier is tall enough to alter the lava's path or slow its momentum, it serves its purpose. When necessary, the wall is raised again and again until the lava either cools naturally or finds a new route. To achieve the required speed, Iceland mobilized a fleet of heavy machinery rarely seen assembled at a single site. Komatsu D375 bulldozers, Liebherr R976 excavators, Caterpillar D11s, and dozens of articulated dump trucks worked continuously. The scale of this operation was not about spectacle, it reflected a harsh reality. Every hour that passed allowed lava to advance further. Only by moving material at maximum speed could the barrier stay ahead of the molten flow. Construction began directly atop lava that had cooled and solidified from earlier eruptions. Over time, this hardened lava becomes dense basalt rock, extremely difficult to fracture. Bulldozers equipped with massive ripper teeth concentrated their full weight onto single contact points, cracking the basalt into manageable fragments. Excavators then loaded the broken rock into trucks, which transported it non-stop to the construction site, where it was compacted layer by layer into the growing wall. Lava has no intent, no awareness, and no strategy. It flows purely under the force of gravity, seeking the lowest terrain and destroying everything in its path. Roads, power lines, homes, and entire neighborhoods can vanish beneath it. In many cases, land must be permanently abandoned after an eruption. Yet in Iceland, the response is not panic or denial. Instead, there is acceptance and adaptation. At times, lava heat is even used to cook food, not as a reckless act, but as a symbol of familiarity with a land shaped by fire. This calm reflects a society that understands the limits of technology and focuses on protecting what can be saved during the time lava barriers provide. However, humans do not always have enough time. When lava flows approach critical areas within mere hours, constructing barriers becomes nearly impossible. This reality was exposed during the Reykjanes eruption in 2024, when lava not only overtopped earthen walls but also broke through sections built over paved roads, where low friction allowed molten rock to pass more easily. In such emergencies, humans have sometimes resorted to extreme measures. In Hawaii during eruptions in 1935 and 1942, military aircraft dropped 600-pound bombs into lava tubes on Mauna Loa. The goal was not to stop the volcano but to collapse the tubes and force lava to spill out higher on the slope. Results were inconsistent. Some attempts briefly slowed the flow, others failed entirely. But in moments where few options remained, intervention was considered better than inaction. History also records simpler methods that proved effective under the right conditions. During Iceland's 1973 Eldfell eruption, seawater was sprayed directly onto advancing lava threatening the harbor. The cooled surface formed a hardened crust, gradually forcing the lava behind it to change direction. While this method cannot stop an eruption, it demonstrates that humans can at times redirect lava long enough to protect essential infrastructure. Ultimately, nearly all lava control efforts are about buying time. And when that time is sufficient, humans do something remarkable. They rebuild, adapt, and even thrive on the land once destroyed. Volcanic slopes, located between 400 and 800 meters above sea level, possess rare natural conditions. Soil formed from cooled lava is rich in minerals such as potassium, magnesium, and iron, essential elements for grapevine development. The porous structure of basalt allows rapid drainage, forcing roots to grow deep and become more resilient. Over time, hills once black and barren transform into lush vineyards. Grapevines are planted in carefully prepared soil mixed with organic compost and volcanic ash, allowing roots to anchor quickly while absorbing minerals left behind by ancient eruptions. After several years, vines begin producing harvests, yielding between 8 and 12 tons per hectare. Grapes are harvested in the cool early morning to preserve moisture, then processed and fermented to produce wine shaped by volcanic terroir. At first glance, lava is synonymous with destruction. It buries homes, swallows roads, and forces communities to relocate. But across history, its meaning does not end there. Lava becomes a measure of humanity's limits, revealing that technology does not conquer nature but adapts to it. Barriers are built not to defeat volcanoes but to preserve time. Explosives are used not to control lava but to redirect it. And after the lava cools, life returns not as it was before but in a form better adapted to the land. From geothermal energy to fertile vineyards, destruction becomes renewal. So what are the true limits of humanity in the face of immense geological forces? The answer lies not in domination but in adaptation. Lava barriers do not stop volcanoes, but they allow humans to protect what matters most. In Iceland, every eruption leaves behind not only rock but knowledge, lessons in patience, engineering, and coexistence. Continue following Mandarin Tech as we explore the extraordinary intersection of technology, nature, and human resilience behind the most extreme geological phenomena on Earth.